And there's about 6 of them. All right. And on the handout, if you flip over a page, I put some blank pages. All right. So you can kind of write some of this graph stuff down. All right. So algebra's common graphs. The very first graph we're going to take a look at is the linear graph or a linear equation. And in a linear equation, the model form is y is equal to x. Now, when we talked about linear equations in the past, or if we talked about a linear equation in, let's say, the intermediate algebra course, it was written out like this: y is equal to mx plus b. Let me go over here. And this is what's called slope-intercept form. And it's y is equal to mx plus b, right? But notice when I put it over here in my little function library, I did not include the m variable. It's like understood to be there. This is a simplified form of this. Okay. So this is y is equal to mx plus b. M is the slope. The slope is the coefficient or the number part of x. The slope, that's the rise over the run. B is what's called the y-intercept. So this should be somewhat familiar, right? So the slope is the rise over the run. B is the y-intercept. And the y-intercept is where the graph touches the y-axis. So in order to write out the formula for a linear equation in slope-intercept form, you only need 2 things. You need to know the slope, and you need to know the y-intercept. Okay. But on my model form, I'm kind of shortening that as y is equal to x. Right? Okay, so if you graph a linear equation, it's going to look something like this. It's going to form a straight line. So we're looking at the equation, we're looking at the model form for the equation, and then we're looking at a rough sketch of the graph. So that's a linear equation. If we move up on the scale of degrees, next we're going to talk about a quadratic equation. And for a quadratic equation, the largest power is a square. And if you were to graph y is equal to x squared, it's going to produce a U-shaped graph. And we call this U-shaped graph a parabola. Some of these things have special names and some of them don't. So a parabola is U-shaped. So that means that whenever you see an equation and its largest power is a square, it's going to produce this U shape, always. All right, now just to see how to graph these things on a calculator, I'm going to pull out my calculator. All right, so if you have yours, okay, you may want to pull it out. We're just going to graph these functions. So if you're using this graphing calculator, here's how you graph. First thing I'm going to do is turn this on, and I'm going to clear out my home screen. So whenever you hear me say home screen, that's this first screen once you turn your calculator on. That's the home screen. In order to graph, I'm going to hit the Y equals button. And if you have a function already in your calculator, I can quickly delete that by hitting clear. Now notice this calculator can graph up to, I think, 10 functions at one time. So you see all these Y equals, you can actually grab 10 functions at once. All right, so I'm in Y sub 1, and if I were to put in Y is equal to X, so notice on this calculator, on this second row, that second column over, you see where it says link, and under link it says X, T, theta, and N. By default, when you hit this key, it should automatically pop up X. If it pops up something other than X, you need to reset the calculator. So is everybody able to press this key and then X pops up? Because if you're in the wrong setting, a T might pop up, a theta, or an N. All right, so it says Y is equal to X. Now, in order to graph, you can simply hit graph. But when you see me graph these things, I'm not going to hit graph. I'm going to hit zoom, and I'm going to hit 6. Zoom 6, it standardizes your calculator, right? So that way when we graph, all our calculators should look the same. So here's what zoom standard means. If you look at this x-axis, it goes from -10 to +10, and in the increments of 1. All right, so if I'm starting at the origin, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to hit this right edge. If I go to -10, I'm going to hit the left edge. Same thing for my y-axis. The minimum value is 10. The maximum value is +10, and then it's going by increments of 1. But notice when I graph it, it gives me that linear curve, a straight line. Next, we're going to graph this quadratic equation, y is equal to x squared. So I'm going to go back to y equals, and I'm going to put in x again, and this time we're going to square it. And if you graph, I'm going to use zoom 6. Notice it forms a parabola or a U shape. So now here's where we're going. We're going to take these graphs, we're going to move them to the left, we're going to move them to the right, we're going to move them up, we're going to move them down, and then we're going to reflect them across the x-axis. But before we do all of that, we want to know what the general shape of the graph looks like. Okay, so for a quadratic, it's a parabola. Next, we have a cubic equation. A cubic equation is in the form y is equal to x to the third power. Notice for any cubic equation, the largest power is a cube, a third power. If you were to graph y is equal to x cubed, it's going to form what's called an S-shaped graph. So I'm going to graph this cubic equation in the calculator. So y equals, I'm going to raise x, so I'm going to use my caret. So this little caret that you see, that's the exponential key. We're going to take x, we're going to raise it to the third power. And if we graph, notice it forms an S-shaped curve. All right. So the next function in our function library is the absolute value. So the basic model form for an absolute value equation is y is equal to the absolute value of x. When you graph an absolute value function, it produces a V-shaped. Right, so y is equal to absolute value of x produces a V-shaped graph. So let's graph that on the calculator. So once again, I'm going to hit y equals. Now the absolute value is kind of hiding in the calculator. So in order to find its absolute value, I'm going to hit math. I'm going to scroll over to CPX. I'm going to scroll down to ABS. Let me just make sure. It's been a while since okay. Excuse me. I'm going to scroll over to number. I think they're the same. I'm going to try. I'm going to scroll over to number. ABS is short for absolute value. It's not going to give you the absolute value bars. It's going to give you a parenthesis, which alludes to the absolute value bar. So if I put in an X, close off my absolute value, and now if we graph, you notice it produces a V-shaped graph.
Well, when I did it did give me absolute value bar.
You must have something other than the 80.
Yeah. I got a TI 84 plus.
I got you. So now if you have 84 plus, you may see the bars instead of the parentheses. Okay. All right. So absolute value is a V-shaped graph. All right. Next, we're going to talk about a square root graph. And a square root equation has a model form y is equal to the square root of x. And if you graph a square root function, it looks something like this. So it's actually like keeps on rising slowly, 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 slowly. But it stops at a point. So notice like this like keeps on going forever. But this it like stops here and it keeps on going. The reason why this one has a stopping point is because you can't have a negative radical. So that's why it doesn't extend the entire graph, the entire domain. All right, so if we were to graph a square root function, I'm going to hit the square root function, which is above x squared, and it's yellow, so it's second, and that gives me my square root. I already have x in my n radical, so now if we graph with zoom 6, all right, so notice what the graph looks like. The reason why the graph looks like this is because when x is 0, what is y equal? Well, if I substitute x as 0, the square root of 0 is what? 0. So that's my point right here, 0, 0. And if I go over 1, when x is 1, the square root of 1 is what? 1. So that means when x is 1, y is 1. So if I graph that, x1, y1, and then so on and so forth. The reason why nothing is over here is because let's say if I take negative 3. When you put negative 3 in, is the square root of negative 3 a real number? It's not. So it's not a domain value, because if I stick negative 3 into this, it doesn't give me a value back. And then if you graph it, it doesn't even reflect on the graph. All right, so that is the square root graph, the basic shape. The next is the cube root. And the cube root functions are in the form y is equal to the cube root of x. Now, some of these things don't have special names, and some of them do. So the square root didn't have a special name. The cube root doesn't really have a special name. But this is what the graph should look like. The graph should look something like this. Right, so if we graph the cube root of x in our calculator, right, so I'm going to go to y equal. I'm going to clear this out. And if I go into math, the fourth function is a cube root key. The fifth function, just in case we need to use it, it hadn't shown up so far. This is called the x root key. Right, so let me show you how to use the cube root. So I'm going to choose this cube root. I'm going to put in x, close off my root. And if you graph, there's no special name for it, but it's like a sideways S. Right. But that's the general shape. Right. Any questions about those? I believe it should be 6 functions. Right. Now, these 6 functions, I'm just going to take a look at a homework problem. You see those things at the bottom of that math palette? Thought I was logged into this. Okay, because you will have to graph functions using the calculator, well, using the XYZ homework layout. And when you use the XYZ homework layout, you see like at the bottom, you see these things, right? This is for what? Parabola. They kind of flipped it upside down, but that's for a parabola. This is a what? Like an S-shaped curve. This is to graph the cubic. This is to graph a what? Square root. This is to graph a what? Cubic. And this is to graph a what? V-shaped absolute value. Is everybody okay with these graphs? Okay. So now we talked about the 6 functions. Now we're going to talk about how to shift them around. Now, in order to see this, we're going to use a calculator, and I'm going to summarize this in a little bit better fashion. But the first thing is to vertically shift something. So vertically means up and down. So you can shift a function up, and you can shift the function down. The only thing you have to do is add a number to the end of your function. So this little f of x that you see, f of x can represent any one of those functions. So f of x could be equal to x. F of x can be equal to x cubed. Remember, in function notation, we simply let y equal to f of x. So f of x is just simply a function. So from what we know now, f of x could be any one of these 6 functions. So that means you can take any one of those 6 functions, and if you add a number to that function, it should shift that graph up C units, and that should make my phone go. If you subtract a constant, it's going to shift your graph down C units. To horizontal shift something, that's moving to the left or to the right. And this is where it's not really so clear. It says to shift a graph to the right, you have to write the model form as f of x minus c. So notice that this minus c is within the function evaluated at x. This c is just simply tacked on to the end. We're going to see all of this stuff with real numbers. If you want to shift a graph to the left, you simply have to add a constant within the function. All right, so here's to summarize all of this stuff up. I am right here. Okay, so we have y is equal to f of x. Right, so we know that f of x can be any one of those 6 functions. Y is equal to f of x plus c. That's a shift up c units. So if you add a constant to the end of your function, that's going to move it up that number of units. Y equal to f of x minus c, that's a shift down c units. Y equal to f of x plus c, that's a shift left c units. Y is equal to f of x minus c, that's a shift right c units. And here's one that wasn't on the previous notes. Y is equal to negative f of x. That reflects across the x-axis. So here are all of the shifts or transformations that are used in this section. All right, so now what we're going to do is kind of see this stuff in action. And I am going to use the parabola. So let me kind of shift this over for a second. So we're going to start with y is equal to x squared, right? And I'm going to put it on the x and the y axis, just a little makeshift x and y axis, right? And if you were to graph that, what would it look like? It's going to form a what shape? Parabola. It's going to form this shape, right? Centered right at the origin. Is everybody okay with that? So like for any one of these things, the first thing you got to do is take your model form, and then you want to look at the basic sketch, right? So this was that basic sketch of y is equal to x squared. So pull this up 1 second just to show where we're headed with this. All right, so I'm just going to go on my calculator, and y is equal to, I'm going to clear that out, x squared, and that's what it looks like, right? So let's say we wanted to take y is equal to x squared, and we want to take that graph and we want to shift up two units. Right? So all I did was just take the basic graph and just vertically shift it up 2 units. How would I write the formula for it now? Okay, and that's where these transformations come in. So if you wanted to take a basic function and you wanted to shift it up 2 units, then how would I write that out? I'm going to use this model form right here, right? Because I'm shifting up 2 units, right? So my f of x is this quadratic. And my quadratic is x squared, so y equal to x squared plus 2 should be the equation. So I'm going to verify that with the calculator. But before we do, is everybody okay? I just added 2 to whatever function, and it's going to move it up 2 units. So I'm going to put that in the calculator. So I'm going to go back to y equals, and if I put in x squared, which is already in here, I'm just going to move over a little bit and put in plus 2. And now if we graph, oops, zoom 6, it shifts the graph up 2 units, right? What if we wanted to take the same graph and shift it down 2 units? That's supposed to be a U shape. What would my equation be? That's exactly correct. Y equal to x squared minus 2. My pen ain't acting right today. So that was shifted down 2. So let's just verify that. So if I go into, I'm going to go back to y equals, and I'm just going to show you this, how you can graph like more than one function at one time. So for my first function, I'm going to put in x squared for my, and that should produce the basic curve. For y sub 2, I'm going to put in x squared minus 2. Now, in order to determine which one of these lines is which, you can actually go into your calculator. I'm going to scroll over to the far left, and you can change what your lines look like. So if I click enter once, it's going to graph a thick line for my second equation, and it's going to graph a thin line for my first equation. So from this point, I'm going to hit zoom in 6. So there's the x squared graph. And then x squared minus 2, it shifts down 2 units. And you can do that with any of those functions. If you take the absolute value function and add 2 to it, it's going to move it up 2. If you take the absolute value function and subtract 2 from it, it's going to shift it down 2 units. Right? So just to show that, okay, for y sub 1, I'm going to put in absolute value of x. For y sub 2, I'm going to put in the absolute value of x. And if I put in minus 2, it should do the same thing it did to the parabola. It should shift it down 2 units. So I just want you to know that this works with any one of those, any function that we're going to talk about. So up and down are okay. So shift down 2 units. Now what about left and right? So we're going to take the same parabola and all right, so when you move something to the left, and if you're on a number line, the left is in what direction? Well, if I'm looking at my x values, if I move to the left, that's going in a negative direction. And if I move to the right, that's a positive direction, right? But when I write out my function, even though this graph shifts to the left, so like right here, we're shifting over 2, the value for c should be positive. So y is equal to x plus 2 quantity square. So this is where it reverses. For up and down, it's straightforward. If it's up, it's positive attached to the end. If it's down, it's a negative attached to the end. If you're going to shift left, even though that's a negative direction, the value you're going to use is positive, and it has to be within the function. So notice what this plus 2 does outside of the function, it shifts the function up. This plus 2 within the function should shift the function to the left. So we're going to put this into the calculator. So I'm going to keep the first function, x squared. I'm just going to overwrite that. The second function, you must put in a begin parenthesis, x plus 2, and then you must square it. So now if we graph, it shifts 2 places to the left. So notice how the positive 2's affect your graph. One is outside of the function, one is inside the function. All right, now we're going to take the same function and let's shift right 2 units. All right, so I'm just drawing a rough sketch of a graph. And we're going to shift over to the right 2 units. So if you're going to shift to the right, then inside of your function, the value for C has to be negative. So in order to shift this to the right, we're going to write this out as y is equal to x minus 2 quantity square. So I'm going to go to y equals, I'm going to go to y sub 2 and just change that plus to a minus. And you should see the graph minus, and then you should see the graph shift to the right 2 units. All right, so that's up, down, left, and right. And the last one is to reflect across the x-axis. So So what would be the equation for this graph? When we go back to the model forms, to reflect the graph across the x-axis, that's this last one. And it simply says that you take whatever your function is and you multiply by negative. So our function is x squared, y is equal to x squared. So we multiply this by a negative, we have y is equal to negative x squared. So if we graph negative x squared, and make sure you use the negative and not the minus. And now if we graph, it reflects over the x-axis. So now we're going to utilize all of the skills we just learned, and we're going to graph. So upon graphing, the first thing is we have to identify the model form. And in order to identify the model form, we simply look at the largest power. And in this case, the largest power is a square. So we would use the parabola, right? So we're going to use this first icon. So as we just look through the icons, notice that this first icon is parabola. The second icon is for a cubic third degree equation. This next icon is for a square root equation. The next icon is for a cube root equation. And lastly, we have the absolute value. So we're going to use the parabola. And when graphing, we're going to start at the origin. Next, we're going to move according to our vertical shift. So notice the vertical shift is that constant that's attached to the end of your function, which is a positive 4. So from the origin, we're going to go up 4. 1, 2, 3, 4. If we look at our squaring function, notice that there is a negative 1 within our squaring function. So we're going to move 1 place to the right. So I'm going to go up 4. That's our vertical shift up. We have a 1 vertical shift to the right. And I'm going to lock that point in. Next, we have to find a second point on the line or on the curve. So taking a look at our function, we have y is equal to x minus 1 quantity squared plus 4. Notice that our graph bends when x is equal to 1. So this actually is our bending point here. In order to find another point on the line, we're simply going to complete an ordered pair. So what I generally like to do is, since I'm located at 1 on the x-axis, I generally like to take either one number to the right or one number to the left. And I'm simply going to complete that ordered pair. So I'm going to take the x value 0, and I'm going to substitute it in the function to produce a second point. And from those 2 points, we can produce the graph. So our function is y is equal to x minus 1 quantity squared plus 4. And we're just doing an x and a y chart. We're going to substitute in x for 0, and we're going to find y. So in my equation, we're going to substitute x for 0. So I'm going to simplify my innermost parentheses. 0 minus 1 is negative 1. If we square negative 1, we have positive 1. And then lastly, 1 plus 4 is 5. So when x is 0, y is 5. So this is the point, second point we're going to graph on our line. So I'm going to plot that point 0, 5. And we have our graph. We'll take a look at another example. And just notice for this example, we have a negative in front of our function. So based on our rules of transformations, that negative should reverse our parabola. Okay? But nonetheless, we're going to use the same procedures to graph. So the first thing we must do is locate our model form. And upon locating the model form, we see that the largest power is a square. So we're going to choose the parabola. Next thing we're going to do is from the origin, we're going to move along our vertical shift. So here again, the vertical shift is positive 4. So I'm going to go up 4. 1, 2, 3, 4. Our horizontal shift should be 2 places to the right. So I'm up 4. I'm 2 places to the right. I'm going to set that point in. Now, just as in the previous problem, I'm going to choose a value to complete an ordered pair. So notice that our graph bends when x is 2, right, on this x-axis. So I'm going to take the number 1. I'm going to substitute it into this equation, and that's going to produce the second point on our line. So this equation is y is equal to negative x minus 2 quantity square plus 4. And we are going to substitute in a positive 1. For x. So y is equal to negative 1 minus 2 quantity squared plus 4. I'm going to simplify my innermost parentheses. I want to bring down my negative. 1 minus 2 is negative 1. Remember your order operations. Please excuse my dear Aunt Sally. So the next thing in the operations is to evaluate our exponent. So I'm going to bring down my negative. Negative 1 squared is positive 1. Okay, bring down plus 4. And negative 1 plus 4 is 3. So we're going to plot the ordered pair 1, 3. So 1, 3. Right? So notice that the graph is U-shaped downwards, which it should be, but that does not affect our left or right movement. Okay, this is always according to the sign of that constant in the function. And we have our graph.